Chimpanzees and Human Evolution. Insights from the Issa Valley. Chimpanzees offer insights into human evolution. In the distant past, the climate of our planet began to transform, turning once lush forests into arid, fragmented woodlands, creating a savanna-like landscape. Imagine a world with fewer trees and more open spaces. This significant environmental change has left scientists scratching their heads, trying to understand how it influenced our ancestors to adopt bipedalism, or walking on two legs. However, there's a twist. The fossil evidence from that era is quite limited, and many of our early human relatives were capable of both climbing and walking upright. So when exactly did this pivotal shift occur, and what prompted it? This is where the Issa Valley chimpanzees come into play. These primates, thriving in conditions reminiscent of ancient savannas, frequently climb trees, particularly when foraging for food. Their behavior suggests that early hominins may have maintained their climbing abilities even as their environment evolved, opting to walk on two legs when necessary, but not entirely abandoning their arboreal skills. As ancient forests dwindled and gave way to open savannas, early humans faced a crucial choice: remain in the trees or venture onto the ground. While walking upright offered advantages for quicker movement and survival, recent research indicates that our instinct to climb did not disappear overnight. Chimpanzees today, inhabiting similar open habitats, still dedicate a significant portion of their time to tree foraging, especially for high-quality food sources. This behavior implies that our ancestors, even as they adapted to bipedalism, clung to their climbing habits. But here's where it gets controversial. Rather than being mere remnants of the past, tree climbing skills may have played a crucial role in the evolution of upright walking by providing survival benefits during times of abundant food and minimal threats. In essence, the transition to bipedalism was not a sudden evolutionary leap. It was a gradual descent, filled with numerous adaptations along the way. Dr. Brianna Drummond-Clark from the Max Planck Institute for Evolutionary Anthropology stated, "For decades, it was believed that bipedalism developed because we descended from trees and needed to traverse open savannas. Our findings demonstrate that effectively navigating the canopy remains vital for a large, semi-arboreal ape, even in open habitats. Adaptations for arboreal living may have significantly influenced the early evolution of the human lineage." In Tanzania's Issa Valley, the landscape features a blend of dense forests near rivers and open woodlands. During the dry season, chimpanzees migrate into the woodlands in search of food. Their habitat and dietary patterns bear a striking resemblance to those of early humans, suggesting that their behaviors could provide valuable insights into our ancestors' lifestyles. Researchers were intrigued. If trees are sparse in this open terrain, why do these chimpanzees still spend so much time climbing? The answer lies in the fact that foraging in trees remains worthwhile, especially when the most delectable foods, such as fruits, flowers, and seeds, are located at the ends of slender branches. The chimps must be agile climbers to safely access these treats. They tend to favor large, tall trees abundant with food. Thus, even in an environment where trees are widely spaced, these chimpanzees exhibit specialized climbing techniques to secure high-value meals. It's a clever trade-off. The more challenging the climb, the greater the reward. This behavior may shed light on why early humans retained their climbing skills long after adopting bipedalism. Evolution was not solely about mobility. It was also about sustenance. Chimpanzees are substantial animals, making movement in trees a delicate balancing act. Instead of scrambling along narrow branches, they often hang beneath them or stand upright, using nearby limbs for support. These behaviors are typically associated with dense forests, yet in the patchy, savanna-like environment of Issa Valley, they prove to be surprisingly advantageous as well. Researchers propose that the evolution of our bipedal gait may have continued in the trees, not just on the ground. Why is this significant? Because apes frequently walk upright while grasping branches for stability. If early humans mirrored the behavior of Issa's chimpanzees, then climbing and walking upright in trees could have been essential for survival in a landscape dotted with food-rich trees. However, scientists emphasize the necessity for further evidence, as this study only examined behaviors during the dry season. Wet season behaviors might differ. Additionally, a more in-depth analysis of the nutritional value of chimpanzee foods could clarify whether the energy expended in climbing is justified by the food obtained. Moreover, since Issa represents just one chimpanzee community, additional research in similar habitats is crucial to determine if these findings reflect a broader trend or are merely a local phenomenon. What do you think? Could our climbing ancestors have influenced the way we walk today? Share your thoughts in the comments. Journal reference. 1. Rihanna C. Drummond Clark, Susan Chege Rubin et al. Foraging Strategy and Tree Structure as Drivers of Arboreality and Suspensory Behavior in Savanna-Dwelling Chimpanzees. Frontiers in Ecology and Evolution. DOI 10.3389/FIVO 2025.156178. https://doi.org/10.3389/FIVO.2025. New study reveals why early hominins clung to tree climbing skills. Imagine this. Despite walking on two legs, our early ancestors still had a knack for scaling trees. New insights from chimpanzee behavior in Tanzania might finally unravel this mystery. A recent study published in Frontiers in Ecology and Evolution delves into why early hominins, who had already begun walking upright, retained their tree climbing abilities. The research team, led by Dr. Rihanna Drummond Clark from the Max Planck Institute for Evolutionary Anthropology in Germany, observed chimpanzees in the Issa Valley, Tanzania, to gain a deeper understanding of this phenomenon. For years, the prevailing theory was that bipedalism evolved because our ancestors moved out of the trees and into open savannas, necessitating a new way to move around. However, Dr. Drummond Clark's earlier work challenged this notion. Her findings indicated that chimpanzees in woodland areas spent as much time in trees as those in dense forests, suggesting that the transition to bipedalism wasn't solely driven by a need to navigate open spaces. But here's where it gets controversial. This new study suggests that the ability to climb trees remained crucial even as hominins adapted to more open habitats. The Issa Valley, with its mix of open woodland and riverbanks, provides a unique environment that closely resembles the conditions our early ancestors might have faced. The diet and habitat of chimpanzees in the Issa Valley mirror those of early hominins, making them ideal subjects for this type of research. We wanted to test if something about how they foraged could explain their unexpectedly high arboreality, explains Dr. Drummond Clark. Arboreality, or the ability to live and move in trees, is a key aspect of this study. In savanna mosaics, where trees are more spread out, the researchers hypothesized that efficient tree foraging behaviors would be particularly advantageous. To test this, they observed the chimpanzees during the dry season, noting what they ate and how they foraged. They also recorded the size and height of the trees in the area. The chimpanzees were often seen feasting on fruits, leaves, and flowers, which are typically found at the ends of branches. This means that climbing skills were essential for safe and effective foraging. Sometimes the food was located on thin branches that couldn't support the chimp's weight. In such cases, the chimps would either hang under the branches or stand upright, using their hands to hold on to nearby branches for balance. And this is the part most people miss. According to Dr. Drummond Clark, these observations suggest that bipedalism continued to evolve in the trees, even after the shift to more open habitats. Observational studies of great apes show that they can walk on the ground for short distances, but they primarily use bipedalism in the trees, where holding onto branches for extra balance is crucial. It's logical that our early hominin relatives also engaged in this kind of bipedalism. However, the lack of fossil evidence makes it challenging to draw definitive conclusions. The researchers emphasize the need for further studies on various aspects of chimpanzee foraging behavior. This study only looked at foraging behavior during the dry season. Future studies of other chimpanzees living in similar dry, open habitats will be vital to determine if these patterns are a common feature of savanna mosaics or unique to the Issa Valley. Dr. Drummond Clark concludes, "What do you think? Does this new perspective change your understanding of our evolutionary history? Share your thoughts in the comments below. Tree climbing chimpanzees reveal secrets of human evolution. New research on bipedalism origins. How much time did our ancestors spend in trees? The study of chimpanzees may provide the answers. A recent investigation into the behavior of chimpanzees living in savanna environments could shed light on some of the most enduring questions in paleoanthropology regarding the evolution of bipedalism. Some researchers propose that the expansion of savannas compelled early hominins to adopt upright walking as a more efficient means of traversing this landscape. However, it is important to note that many early hominins were still well suited for climbing. The findings from this study indicate that chimpanzees residing in a savanna mosaic ecosystem continue to forage in trees, spending a significant amount of their time in these elevated spaces to seek out the most nutritious and plentiful food sources. This suggests that the adaptations for life in trees remained essential for the survival of early hominins, even after they began walking on two legs, and may have even played a role in the evolution of bipedalism itself. Determining the exact moment and reasons our ancestors descended from trees to walk upright is a complex puzzle. Many early hominins capable of bipedal movement were also adept climbers. And there is a notable lack of fossil evidence from a crucial period when climate changes transformed dense forests into open, dry woodlands known as savanna mosaic. This transformation may have driven hominins to the ground. However, the recent study of modern chimpanzees offers a potential solution to this mystery. Researchers observing chimpanzees in the Issa Valley of Tanzania have discovered that, despite their savanna mosaic habitat, these chimpanzees frequently climb trees to access valuable food resources. This behavior may help explain why early hominins retained their tree-climbing adaptations. Dr. Rhianna Drummond-Clark from the Max Planck Institute for Evolutionary Anthropology, who led the study published in Frontiers in Ecology and Evolution, stated, "For decades, it was believed that bipedalism developed because we descended from trees and needed to traverse open savannas. Our findings demonstrate that effectively navigating the canopy remains crucial for a large, semi-arboreal ape, even in open habitats. Adaptations for life in trees, rather than on the ground, may have significantly influenced the early evolution of the human lineage." Habitats and hunger. The Issa Valley features a mix of dense forests along riverbanks and open woodlands. During the dry season, chimpanzees tend to forage more in the woodlands, where food is more abundant. Their habitat and dietary patterns are similar to those of some early hominins, suggesting that studying their behavior could provide valuable insights into the lives of these extinct relatives. Dr. Drummond-Clark noted, "Our previous research indicated that Issa Valley chimpanzees, compared to their forest-dwelling counterparts, spent an equal amount of time moving through the trees. We aimed to investigate whether their foraging behavior could explain their surprisingly high levels of arboreal activity. Savanna mosaics are characterized by trees that are more sparsely distributed, leading us to hypothesize that adapting their foraging strategies to efficiently utilize trees would be particularly advantageous when the next tree is farther away." Researchers closely monitored the adult chimpanzees in the Issa community during the dry season, observing their foraging habits and dietary choices. They recorded various factors including the size, height, and shape of the trees, as well as the number and size of branches. The Issa chimpanzees primarily consumed fruit, followed by leaves and flowers, foods that are typically found at the ends of branches, necessitating strong climbing skills to access them safely. They tended to spend more time foraging in larger trees that provided greater food availability. The longest foraging sessions and the most specialized behaviors for navigating thinner terminal branches were observed in trees with expansive crowns that offered abundant food. This suggests that the nutritional fast food. Due to their relatively large size, chimpanzees navigate within trees not by climbing on slender branches, but by hanging beneath them or standing upright while grasping nearby branches for support. While these safe behaviors are typically associated with foraging in dense forests, the findings indicate that they are equally important for chimpanzees foraging in a savanna mosaic environment. Dr. Drummond Clark suggested, "We propose that our bipedal gait continue to evolve in the trees, even after the transition to an open habitat." Observational studies of great apes show that they can walk on the ground for short distances, but they predominantly use bipedalism while in trees. It stands to reason that our early hominin ancestors also practiced this type of bipedalism, where they could hold onto branches for added stability. If the Issa Valley chimpanzees serve as appropriate models, and both suspensory and bipedal behaviors were likely crucial for the survival of large-bodied, fruit-eating, semi-terrestrial hominins in open habitats. Nevertheless, the researchers emphasize the need for more fossil evidence and further studies on various aspects of chimpanzee foraging to validate this hypothesis. Dr. Drummond Clark cautioned, "This study focused solely on foraging behavior during the dry season. It would be fascinating to explore whether these patterns persist during the wet season." Additionally, analyses of the nutritional value of foods and overall food availability are essential to test our hypothesis that a strategy of foraging longer in large trees for specific foods is energy efficient in an open habitat. Importantly, this research only examined one community of chimpanzees. Future studies involving other chimpanzee populations living in similar dry, open habitats will be crucial to determine whether these patterns are indicative of a broader savanna mosaic trend or unique to the Issa community. What do you think? This research opens up intriguing discussions about the evolution of our ancestors. Do you believe that tree climbing adaptations played a more significant role in the development of bipedalism than previously thought? Share your thoughts in the comments.